Hi there. In this video, I will walk you through how to implement a simple text adventure game in Apple BASIC. So I've been a software developer for more than 20 years, and I learned programming using an old Apple IIe, pretty much like the one you see in the background. And programming has come a long way since then. Our programming language look different, our development tools look different, our computers look different, and I thought of sharing some of this journey with you by taking an example of a simple program. And in this case, I have chosen Text Adventures because it's a very dear game style to me. That's what got me hooked by the computer and into programming in the first place. So my idea is to take this simple game. We could even call it a proto game in the sense that it's not a full-fledged game, but it has all the essential parts that is playable, but it's still simple enough that we can grasp it in under an hour, let's say. However, it's sufficiently complex that we can really see the mechanics of the programming language working and how things evolved over time. So this is the first series of videos in a longer series that I intend to make covering different generations of programming language. We start with BASIC because that's a programming language that many people in the 80s and early 90s got into computing. That's how I got into computing. And then we are going into structure programming language like C, and then we are going into object-oriented programming language using probably Smalltalk, and we are going to try our hand with functional programming language. I'm thinking some dialect of Lisp. Let's see how it goes. And my intention is to cover this programming experiences using platforms that are representative of the age that these languages were thriving. So our first series of videos, we are going to program the simple text adventure. I'm calling it GetLamp in homage to the GetLamp documentary, an excellent documentary on text adventures. You should search it up on YouTube. You can find it. And please watch it. It's awesome. So we're gonna take this simple GetLamp proto game, and we are going to implement it using the Apple IIe. I'm not using this actual physical hardware because it's kind of bad to have video footage on this flickering screen, so I am going to use an emulator, but it's pretty much like the original experience, and I will provide links to the tools that I'm using and to the source code on GitHub. So I hope you have fun. So let's take this from the top. I'm emulating an Apple IIe computer. So I'm going to control reset to get the Applesoft BASIC prompt. And to start with, a text adventure has this loop where the user is informed. Let's say you are in an empty room, and then you get a prompt and you can enter comments. And your comments are going to affect the game world. And then, you get another description. Maybe that you're in another place, maybe that you're still in the same place, but you have different objects or different NPCs and so on. So we have this loop where you get some information and then you have to provide a comment. In BASIC, we always start with any program line. It has to start with a number. That's kind of a label of that line. So we start, I'm gonna randomly start at line 100. And here we can type in a command, for instance, print you are in, oops, in an empty room. And yeah, here's our first command. So the next one, we want to get some user input. And there's a command for that. It's called input. And then I'm gonna just use this as a command prompt. And now the user will type something, and whatever the user types will land in a variable. So I'm gonna call this variable input. Well, it's a bad name because it's a reserved word actually. So I'm gonna just call it in. And dollar is the sign of a string variable in BASIC. And just for debugging purposes, I'm gonna echo whatever the user is typing here. So yeah, we're just printing to the console what the user typed. And let's provide a means to exit the program. We say if input string it's equals to quit, then we quit the program. So this is how it looks like right now. Let's run it. You're in an empty room. We're out of the program. Whatever we type here, we are just echoing it. Oh, and also we're missing the loop. So we show the status, we get the command, and then we should do it again unless it's the quit command. So I'm gonna add a line here that say, okay, when we reach line 140, we go back to line 100. Then we run it, and then just type whatever, just echoes. But if we quit, then the program is over. So that's yeah, quite a simple exercise, but you can see how this is the foundation that we are going to build the entire thing upon. You notice that here we are in a world where we don't have functions, we don't have subroutines, we don't have local variables. We just have these variables like our input variable, and they are all global, so you have access to them in any part of the program. And you have these commands that allow you to control flow, like the goto, but not really call named functions, pass parameters, any of the things that we are used to in more modern languages. So the next thing we need to add is navigation, right? We need to be able to navigate our map and go from one room to another. So yeah, let's get into it. Okay, so we need new variables to say where we are, in what location we are, and also to describe the locations. Let's add a new line of code saying that we start at a location 1. So L, the variable L, is pointing to the room where we are. And we are going to use an array of strings to hold the description of the different locations. The way you dimension an array in BASICs with the command dem. Then I'm going to call this location description LD, dollar because it's a string. And we'll have positions from 0 to 4. And in order to populate we need to define some constants. In BASIC, we use the command data to do that. So the first room is an empty office. Then the second room is the janitor's room. I'm just breaking the line so it's easier to read. We can have as many separate data lines as we want. So room number 3 is the classic A dark room. And finally, room 4 is the world outside. So how do we use this thing? Actually, let me just list lines 10 through 99. It's our initialization code. So we have these 4 constants. Now we need to put this into the location description array. And to do that, we need to loop. I'm gonna use a numeric variable I. 1, 2, 4, number of rooms we have. And then we read. And every time we call this read thing, we are taking one constant that we previously defined with data, and we are feeding into the variable that we name here. So it's location description I, because I it's the current iteration. Then next I. So this is a loop. It's going to loop from 1 to 4, and every time it loads into one of these LD dollar variables. And now we need to modify this loop so we are dynamically indicating where we are. So I'm going to type here print URN space, and here we say it's the location description of the location L, and we start position 1, as you might recall. And we don't need line 100 anymore. I will just put a comment. So REM as in remark, that's how you comment on Applesoft BASIC. So this is the main loop. And our code also, we can say that this is the init variables. So we have nice descriptions of the different sections of our code. But I expect now, if I run this, instead of saying that I am in an empty room, it will say that I am in an empty office. So let's go on and give it a try. Yeah, it works. Next thing is we need to move from one room to another. So we need to introduce a new command that the user can type. That's the command go. This way you can go in a certain direction. You can go south, you can go west, and so on. I will add a new line just after the quit command. We want to check the left part of the string if the first two characters are making the command go, we use the command, the basic command left $. Then we say, yeah, this is the variable. And these are the number of characters I want to compare. So I'm taking the leftmost two characters of the variable input, and I'm checking if they are equal to go. Then I have to do something, and I'm going to move these to a subroutine. So that's a way to organize your code. We are going to branch to a different line number, and they're going to do a number of things. And when we are done, we're going to return here to this line 135 and continue from here. And the basic command for that is go sub, and go to subroutine, and a line number. I'm going to use 1000. Just a quick remark. This makes the program more readable. 9000, again, I'll put something here. To make it more readable. And then we have to do something. And this something is we need, depending on the direction informed by the user, we need to go somewhere. But this somewhere depends also on where we are. So basically on two things, right? Where we are and where we want to go. Way to handle this is to create a matrix. So it's a matrix where the first dimension is the room where we are. It's kind of the source of the movement, the origin of the movement, where we start the movement. And the other dimension is the direction. So we have 4 dimensions. So we have north, south, west, and east. And this is a job for the initialization of variables. We're going to add something more here. So I'm going to start at line 60. And I will dimension a new array. In this case, it's going to be a 2-dimensional array, hence a matrix. And I'm going to call it location exit. And this is a numeric variable, so we don't need to put the dollar to make it into a string. And the first dimension can have up to 4 different positions because we have 4 rooms, 4 locations, and also we have 4 directions. So this is the size that we need for our matrix. And we need to populate it with some content. So the first room, let's think about north, south, east, and west. So can we go north? No. So I'm going to use 0, meaning this direction is blocked because we don't have a location 0, right? We have locations 1 through 4. Then can we go south? Yes. If we go south, we go from the empty office to the janitor's room. So from room 1 to room 2. And that's pretty much the only thing we can do from room 1. So room 2, we can go back to room 1. Later we can come and add more rooms. So we can go from room 1 to room 3 via the direction east, but only after you unlock the door. The next thing we need to do is read these constants and populate our location exits matrix. So we're going to need 2 loops for that, one for the first dimension and another one for the second. So we do for I 1 to 4, and then for j 1 to 4, then we read into location ij, and next j, that's the inside loop, next I, that's the outside loop. So for each location, it's going to populate the 4 directions and then move on to the next location and so on. Now we can go back to our subroutine. What we do here is, you might recall that we checked for the left part of input, if it was the same command as go. Now we have to check the right part. So if right of input, the last 5 characters, the rightmost 5 characters, if they are north, then the new location, it's going to be the location exit that's in the current location, direction 1. Direction 1 is north. However, we have a kind of a problem here, right? Because if this direction is in, we cannot go in this direction, which is the case with room 1. Then, yeah, we cannot change L. So one way to deal with this is we store the value of L into a buffer, to a temporary variable, before we change anything. And then later, if L equals 0, which means that when we reassigned, it ends up with 0, then we print you cannot go in that direction. And we say that L equals buff. So it's basically assigning the value that it had before we set it to 0. And then we can return from the subroutine. So we are only dealing with direction north. So we have to do a similar thing for the others. So if right string of input string 5 last characters. It's south, then L equals location exit L direction 2, right? That south is direction 2. And let me quickly type the same for east and west. Okay, so here we are. I had to retype line 1030 twice because I forgot the $sign after the command right. This is what our program looks like right now. So listing our main routine between these lines. If the command line starts with go, then we go to subroutine 1000. And there we first store L in a temporary variable, and then depending on the direction, we set L to the new direction. If it happens to be 0, which means we cannot go in that direction, we let the user know and return the location to what it was before, and then we return. And when we return, we go to that line 135, and then we go to line 100 and we restart the loop. So let's see how it goes now. Oh, this error happens when we are short of our data instructions. So, yeah, I know what happens. The problem is I did not put the data for rooms for rooms 3 and 4. So you see we have lines 65 and 68 where we are populating just 2 of the rooms. So I'm going to add line 69. Oh, 69. And you see this is why we leave some space between the lines, so we can always put more stuff in there. So let me check what is the right data here. So for the third row, the only thing we can do is go back to the first one when we go west. And for the fourth row, we have if we go north, we can go back to row 3, and we cannot do anything else. So now we have 4 times 4 directions, so that loop will be satisfied. Let's go. Okay, you are in an empty office. And now I can try going south. Yay, I'm in the janitor's room. It's working. If I try to go east, I cannot. But I can go north, back to where I was. That's pretty much what I can do for now. So this shows how we can go about the map. Recall, we have a locked door between rooms 1 and room 3, and we need to find a way to unlock that door. And that's the next thing that we are about to see. There's a number of ways that we could deal with this problem. The one I prefer in this case is to change the state of our world. To express what I mean, let us revisit our variable initialization. And let's change a bit the description of the first room. So we say you are in an empty office. There is an exit south and a locked door to the east. And of course we need to put the janitor's room. Looks good. So what happens now is that it says that we have a locked door to the east. So you try to go east and you cannot. And now, based on the description, you understand why. Our main loop. Now we have to take into account another command, and that command is unlock door. Later we can add a check. So you need a key to do that, for instance. For now, I'll just allow that we do it without. You can just go and unlock the door. So if input is unlock door, then we go to a new subroutine. I'm gonna put this one at line 100. And now line 100, we say so we change the description of the first room. So we say that location description of the first room now becomes an empty office. There are exits south and east. And also now we say that the exit from room 1 direction east takes to room 3. So we are allowing the user to go to room 3. It would be nice to just inform the user the door is unlocked. Then we return from the subroutine. So unlock door, go east, and now we are in the dark room. So we cannot go nowhere from here. Now we can put objects like a lamp, and then you need the lamp to find the exits here. So think I will stop here typing the program from scratch, and I will load the complete program, and then we can review how it looks like. But I think you should by now have a good idea of how it goes. It's all variations of the themes that we explored so far. Okay, so I have rebooted our virtual computer with the disk operating system and the virtual floppy with our data. So let's confirm it's there. Yes, in our floppy we have an Applesoft program called getLamp. Let's load it. Okay, now the program is in memory, but of course it's too long to fit the screen, so we need to go through it bit by bit. Going to start with these lines. So we start initializing our variables, and you can see there that we have our location description array and our location variable, just like we had before. We have better descriptions using lowercase, which definitely is easier to the eyes. And we are populating we have this loop in lines 40 through 44, populating the location description. And then if we list lines 50 through 80, oh, it fit perfectly the screen. So here it's where we are populating our matrix of direction, so from which room you can go where. And we define the data between lines 51 and 56. And then we have that two nested loops in starting on line 58 through line 66, where we already covered that. And on line 70, we have a bit of a new thing. It's objects. So objects, they can be picked up and they can be dropped and they can be used. So in our case, because the number of objects, we might increment it later. There's a variable OC for object count. Actually, it's more a constant. We're not going to change it. And then we have a array of strings called object description, OD string, very similar to location description. And then we have an object location array. And this one is an array that we have as many positions as there are objects. And if something is in let's say an object is in room 1, then the object location is 1. And if the location is 0, that means the object is with the player. It was picked up by the player. And then line 72, we say that we have two objects, in our case, to be a lamp and a key. And then we dimension an array for the object descriptions and another for the object locations, both of size 2. Then we have the data. And we have a single loop on lines 76 to 80, where we are basically reading the locations and the descriptions into the arrays. Then we can really go to start a game. So this we are going to do between lines 85 and 95. All we do is we clear the screen. That's this home command on line 90. We are clearing the whole screen. And then we print a short banner. And then we get into the main loop. So the main loop starts at line 100. And I will go until line 170. Let's see if it fits the screen. Oh, a bit too much. Let's take this in smaller chunks then. So the main loop, we start saying, yeah, you are in a location description. And then we go to a subroutine, display objects. So that one, it's in here. Oh, there's a weird character there. And here we have the subroutines. Basically, we are looping over the array of object locations. And if the object location matches the current location, then we print UC and then the object description. And this will loop through all objects. So if you have two objects in the same row, it's going to say you see a lamp, you see a key. And then it returns. So back to lines 100 through 120. So we print the location, we print the objects in this location, and then we give the familiar prompt asking for an input. Let's see what happens between lines 125 through 190. Oops, too much. Again. So 125 through, I don't know, 158. Now it fit perfectly. So we start defining this variable OK, and this is a Boolean. So we don't have the concept of Boolean, of true or false, we just use integers. So 0 is false, 1 is true. And you're going to see later why I'm using this variable, but I start saying it's false, so it's not OK. And then we check, is this the go command? If it is, we go to the go subroutine. That one is on line 1000. Exactly what we've saw before, right? So this one should be familiar. So let me go back to lines 150 to 170. So we check command by command, and then we have a command inventory. I'm gonna go take you there later. In the command take, the command drop, and light lamp, unlock door, and help. And on line 170, we notice why we had that OK variable. You see that every time that I successfully identify a command, I'm making the OK to become 1, to become true. So that's happening in every single line, 150, 152, and so on. So it's if the command is identified, then OK equals 1, and then we go to the subroutine. So if we got to line 170 and OK is still false, it's still 0, then means we could not identify any command. Then we want to let the user know we don't know what the hell they are trying to say. So we just say what? That's what line 170 does. And finally, at this point, we're going to check if the user is in location 4, in the 4th room, because if you are here, that means the game is over. You won. Otherwise, you have to continue, go back to the beginning of the loop. So this is between lines 200 and 250. We just check. If location is different than 4, that's line 210, then we go to the main loop again. Otherwise, we say you are in location description of room 4, which is in the outside world. Congratulations, you have won the game, and we quit. And after that, all we have is the subroutines that are all starting with the line number 1000. So all the commands there. We have already seen the routine for the subroutine for displaying objects. That's on line 1100, and also the go command that's on line 1000. So let's see what we have on line 1200. So that's the inventory command. You are carrying, and then we loop over all the objects, and if the object location is 0, which means the player has it, then we print as part of the list, and then we return. Next command. So we are about to take an object. And first we need to identify this object. And I'm using a global variable called obj to identify that object. So that obj, if it is 1, it means it is the lamp. And if obj is 2, it means it is the key. And yeah, that could go on for other objects. We only have these 2 now. And we cannot take something that's not in here. And that's what line 1310 is testing. So if the object location of the object the object in question is L, is the current location, then the object location becomes 0, which means with the player, and we picked up the object. And line 1380, if we get here, it means the object location was different than L, means we cannot pick up this object, or we could not identify the object. So we just say, we don't see that object in here, which means either we don't know what object it is because we could not identify it with obj, or it means that this object is somewhere else. Then we return. So let's take a look into subroutine for identifying objects. That's on line 1500. Oh, I have a weird character there. So you see that we start initializing this object to 0. And 0 means no object, because our objects start counting on 1. And then if the right part of the command, the object of the verb is a lamp, then object is 1. If it's key, then object is 2, and return. So when we return, either object is 0, which means we don't know what the hell it is, or object is either 1 or 2, the lamp or the key. Line 1400. Let's see what subroutine we have there. That makes more sense, right? So this is the drop, and drop, we again identify the object, and then if it's 0, which means you are carrying it, we make the location become L, the current room, and we let the user know you have dropped it. Otherwise, we don't know what this object is, and then we say you don't have that object, and we return. And we have a couple more subroutines. So on line 1600, this is the light lamp. We already know this one. Well, I'm sorry, we don't know this one, but it's very similar to the unlock door. It's basically you need to have the lamp, otherwise you cannot light it. And when you light it up, then we change the object description to it's not more a lamp, now it becomes a lit lamp. And we change the description of room 3 to it was before a dark room, and now it becomes an empty room. You see doors leading west and south. So when we get in room number 3 the first time without the lit lamp, it just says it's a dark room, and also you cannot go anywhere. And when you light up the lamp, then we have a new description for the lamp, and also we have new exits in the room. You see that in line 1620, and you have an updated description for the room. Line 1700. This is the unlock door. And yeah, we have already covered this one. And finally, we have a help subroutine. That's on lines 1800 and later. So it's just we suggest the verbs that are possible, right? Like go, take, drop, inventory, light, and unlock, in case the user is puzzled what actions are possible. And that's it. That's the whole thing. Let's go for a spin then. Run. Okay, get lamp, a short text adventure. It's a very long sentence. It's breaking. Doesn't look good, but yeah, that's not that important. You're in an empty office. There is a door to the south and a locked door to the east. You see a lamp. Okay, there's a locked door. I'll try going east. Anyway, now I cannot. All I can do is go south. So let's try south. So this is the stock room. And here we only see a door to the north. Yeah, that was called the janitor's room in the previous version, but yeah, it doesn't really matter. Oh, there's a key in here. So, key. Okay, I have a key now. If I type inventory, yeah, I'm carrying a key. Let's go north again. Back to the empty office. And now that we have a key, we can unlock the door. Yay. Let's go east. Oh, I'm in a dark room and I cannot see a thing. I want to go south. I cannot go. I mean, it's dark. I don't see anything. So all I can do is go west, back to the empty office. And now I take the lamp. And then I light the lamp. Oh, I have a key and a lit lamp. So now I can again go east again. Oh, now I can see I'm in an empty room and there's a door south. Well, there's also a door west, but that just takes me back to the empty office. I want to see what we can find south. Yay, I won the game. So, what are the main takeaways from this exercise? First thing, if you're familiar with any modern programming language, if you're watching this video, you certainly are, you are used to declaring functions and specifying parameters and having return values. And you see, we have nothing like this here. Well, to be honest, we have something that's slightly like this, but still, yeah, full of limitations. And those are the subroutines. So when you, in a modern programming language, when you call a function and you pass some arguments, you can have local variables inside that function. You can really shield what's going on inside that function from what's going on outside that function, and you can organize your code much better. And here it's everything is global, and all the communication happens in these global variables that we defined at the beginning. I think the ugliest part of this code is around the identify object subroutine. So let's take a look at it again. So the reason why I'm using a subroutine, it's I want to reuse this piece of code because both for taking objects and for dropping objects, I need to identify the object in question. And yeah, I don't want to duplicate this code. And that's why I reuse the subroutine. But I need to return something from the subroutine. And what I need to return is what is the object? It's the index of the object in our object array. So I need to return a scalar numeric value. In this case, it's represented by the variable obj, variable object. But I cannot really return a value because this is not a proper function. So I have to use a global variable. This object is a global variable. So I'm calling this subroutine, for instance, from the take object command. And then I call it on line 1305. And then the next line, I am already using this obj variable, but I'm not declaring it here. It was declared in there inside the subroutine. And this is a very sort of promiscuous relationship between these two routines because they know details about each other. But that's how things rolled in BASIC. So that's what we had, and we had to make do with it. And you can see that if you structure your programs with subroutines and you have reasonable variable names and you have a strategy to document your program with comments, they become more readable, but it's a challenge. I mean, this whole program has under 100 lines of code, and it's still, I mean, if we spend like a year without looking at this and we come back, it's hard to see what's going on here, especially because we are very limited in what we can see on the screen. And we had no scrolling, we had no full text, full screen editors back then. So if you really wanted to have the big picture of your program, you needed a hard copy. You printed this thing on paper. And then you had this long paper trail that you could just pick a pen and you would kind of interpret the program with your mind and debug it. And the good thing is that we ended up doing a lot of validation of the program while going through it and thinking through it. And today, because we have a lot of computing power and it's very easy to just type something and rerun it. We do it more often. But still, this is a very primitive way of programming, and everybody's glad that the world has moved on. This has a lot of nostalgia and a lot of emotional value to it, but we could not have the modern world if programming was still like this. So this was the first step in our journey towards implementing this game in several programming languages, following the different paradigms that we created over the decades until we reached the modern languages. So I hope you have enjoyed this. And yeah, come back for our next exercise. Bye bye.